So what determines how an association develops? We'll see that it's a little bit different than what Pavlov originally assumed when he did his early studies with the dogs and the meat and measured their salivation. So we have these 5 general principles. The first one is temporal contiguity, and that's just that there is better learning if the CS and the US occur close together in time. So that the CS and US have to occur in a close period of time, and the better that happens, the more likely an association will develop. And that makes sense because if something happens, now, and then something else happens 4 hours later, there's probably not real cause and effect there, which is why, like in dog training and so on, if you are coming home from work and you see a puddle of urine that's maybe several hours old, there's really not much you can do at that point because there's such a big gap between the time that the dog weed on the carpet and the time that you got home and noticed it. So anything you try and do at that point is just not going to be very effective because of the lack of temporal contiguity. Another principle that we've learned about how associations develop is that the CS should provide some valuable information about the US. It should predict what's going to happen. And if it does this, then there's probably a good CS and you'll develop a good association between that CS and the US. Third one is that as the intensity of the stimuli increases, so will the speed of the learning, the rate of learning. So we learn faster if the stimuli are more intense, they're more obvious, they're more attention-getting. And that just reflects the fact that we learn about things that grab our attention better. The fourth thing that determines how an association develops is that the more times the CS and US are presented together, the stronger that association will be. So kind of practice makes perfect, right? More experience with CS and US, the stronger that association. And then finally, similarity, and this comes from the taste aversion study, and it just says that some CSs and USs go together. So the taste aversion study is just one type of study that shows that some CSs and USs go together. There are a whole bunch of other ones that also demonstrate that some conditional stimuli and some unconditional stimuli just seem to go together. But a good rule of thumb is that if the unconditional stimulus happens inside of our body, it's an internal sensation, then the conditional stimulus should also be internal, like a taste or some other sensation. If it's happening outside of our bodies, then both CS and US should be outside. And so we've learned that there's an adaptive value of classical conditioning. And so if we ask, why do we develop pavlovian conditioned responses, we can answer in terms of the selective pressures that humans and other animals have experienced. So basically it's about enhancing survival and reproduction, right? Then we just need to explain, well, in what way are conditioned responses adaptive then? How do they help provide improved survival and reproduction? And so if we think about it, conditioned response should help us deal with the situation better. How do some of the CRs that we've looked at do this? So think of the salivating in the dogs that Pavlov studied, right? So salivation is part of digestion, and so it actually does improve digestion, and it is the first step in breaking down what we eat. We also looked at insulin release, and so if you drink Coca-Cola, right, you drink a Coke, it has sugar in it, and that triggers the release of insulin by the pancreas to bring down that sugar level. If you drink Coke regularly, you probably develop the conditioned response where your body will start to release insulin before the Coke is actually in your mouth, and that helps prepare your body for the coming sugar so that you don't ever really get a sugar spike. So it helps us in that way. We also had the example of avoiding the teacher if the teacher yelled at the student, right? And so in general, if someone is hostile or aggressive towards us, it makes sense to avoid them. That will also enhance our safety. And then finally, avoiding foods and drinks that have been paired with feeling sick makes sense because, well, they might be poisonous, right? And we can also look at how under the same idea of conditioned responses being adaptive, there are conditioned responses to drugs as well. We can call that conditioned drug tolerance. This is very similar to the insulin being released to deal with blood sugar. So the body has made changes to compensate for the presence of a drug, for example, like alcohol, so that the user feels fairly normal when using that drug. And the symptoms of conditioned drug tolerance are usually the opposite of a drug's effects. Why? Because they're opposite because we need them to compensate for the drug. They have to counteract the effect of the drug. And these effects only occur when in the presence of these drug-related cues. And so many people have noticed that if they normally drink alcohol at a bar or some other place like that, like a restaurant, that they start to develop what's called tolerance, right? Their body starts to compensate for the effects of the alcohol so they don't get as drunk. But if they drink alcohol all of a sudden, like at a work-related function or something like that, they might get really drunk very quickly. And that's because in that other context, they don't have that conditioned drug tolerance. If they normally could drink, say, 2 alcoholic beverages and not feel drunk, without those conditioned reactions, without that compensation for the alcohol, they cannot drink as much, and so they're going to feel drunk. So conditioned drug tolerance is how we can associate a particular environment or set of people with use of a drug like alcohol and become tolerant specifically in their presence, but not have that same level of tolerance in a different environment.